Morning. Sorry, I just had to get that done really quickly. Okay. I'm not even at a full viewership yet, so I figured, why not? Hope everyone's doing well. Check it out. I made this. I made 2 of these throwing knives yesterday. I gotta say, this is like a really pleasing shape. I think. Like, this looks pretty gosh darn good, I have to say, as a throwing knife. All right, so I am going to go ahead and get started. First thing I want to say is that today's lesson has no assignment attached to it. So, gosh, why did I say that? Now you're not going to pay attention. Oh, I'm so dumb. Well, it's useful information, but there's only one assignment this week, and that was the one that corresponded to Monday's lesson. Okay? So, but this is good stuff. It's important stuff. Why did I do that? So let me go ahead and get started. This is SL. 2, 4, and I need to zoom in one more and autofocus. Cool. Okay, so what we are going to do today is why does that look weird? Okay. What we're going to do today is we are going to talk about electric field lines. Okay. And yeah, so there's no assignment for this. The reason is that we're not in person. So if we were in person, I would have you do some artwork based on electric field lines. But we are not in person, and I have no way to really collect artwork, so I'm not going to do that. So what electric field lines are is they are a picture of the electric field pattern due to some charges. All right, and here's the nice thing, is that unless you're making the electric field lines with a, unless you're making those field lines with a computer, which we're not going to be doing, it is an approximate picture. Okay. So basically there are some rules. Okay. So let me go over the rules of drawing electric field lines. So remember, charge is what makes an electric field. Okay, electric charge makes an electric field. Okay, so if you have a single charge, let's say you have a charge that is +1, a positive charge. So there's your positive charge right there. The electric field lines go directly away from that charge. Okay? So electric field lines have directions, so we have to put the direction of the electric field lines. Okay, so the electric field lines point away from positive charge. All right. Now I have drawn 4 electric field lines. Okay, but you get to choose you get to choose how many lines corresponds to 1 charge. All right. So I decided that +1 charge is 4 lines. I would probably not go fewer than 4 lines, okay, because then the picture gets really, really approximate, okay? So more lines is better within reason. And here's why you don't want to do too many lines for 1 charge, because if you were to draw the electric field line pattern for a +2 charge, if +1 has 4 lines, then +2 charge has 8 lines. So the number of so the amount of charge corresponds to the number of lines that are coming out of that charge. Okay. So I have the 4 that I have for a +1 charge, but then I also have to have 4 more. All right. And then field lines need directions. Okay. If you had 1.8 charge, a charge of +1.8 or something, then that's somewhere between 7 and 8 lines, so it wouldn't really matter in that case. But basically, the number of lines is related to the size of the charge. Okay. So however many you decide one is. If I decided that +1 has 3 lines, then +2 better have 6 lines. If I decided that +1 has 10 lines, then +2 would have 20 lines. Okay? So it just kind of depends on the amount of detail you want to have. If you have a negative charge, what are you doing in there, bugger? If you have a charge of -1, okay, the electric field lines go in. So because +1 had 4 lines, -1 is also going to have 4 lines. But the difference is that these field lines would go into the negative charge. Okay? So field lines go away from positive charge. Okay? And they go towards negative charge. All right? So that's kind of the first part of how electric field lines work. Second part is this. So if you just have a single charge, the lines just go out to infinity. Okay? But basically, field lines bend due to the presence of other charges. Okay, so so for example, what if you had a +1 charge, okay, next to a +1 charge? All right, so what's going to happen is, this +1 charge has a field line that goes out, and this +1 charge has a field line that goes out. But you can see that these two field lines are on a trajectory to like meet each other. Field lines cannot cross, so they bend to avoid crossing. Okay, so what's going to happen in this case is the field line is going to bend up like that. Okay, and here for this field line and this field line, they are going to bend down like that. All right. So this pattern kind of looks like this. So this is a universe where 5 lines is a +1 charge. So I always want to draw the direction on my electric field lines. Like so. Okay. So that's if you have a positive next to a positive. Now, what if you had a positive next to a negative? All right. So what's going to happen in this case is that, this one has a field line that's going out. This one has a field line that's going in. So the field lines end up just connecting. They link up like that. Okay. They link up. So they kind of do this type of a pattern. Okay. So that's a positive next to a negative. To me, this always looks like cell division. It's like metaphase plate. Metaphase plate. Looks like metaphase plate. Let's see. Prophase, metaphase, anaphase, telophase. Are those the phases of cell division? I don't know if they're in the right order, but I think those are the 4. I know prophase is first. I know meta is probably in the middle somewhere. And I think telophase is the last one. So I don't know. So to me, that looks like cell division. So again, we have a universe where +1 is 5 lines, and then therefore a -1 is also 5 lines, but just going in. Okay. So what if you had, for example, an unequal distribution of charge? So what if you had, for example, a +2 next to a +1? And I'm going to draw this a little bit smaller just so I can fit it all. So maybe +2 has 10 lines because +1 had 5 lines. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. Okay? So what happens in this case is, see how it's +1 to +1? So it's equally balanced. Like this is a line of symmetry. Okay? Because this is a +2, its field lines are going to kind of dominate the other one, which means that they go straight for longer before they start to bend. So it'll kind of, the lines will go out and then start to bend only after they get pretty close. Like this, okay? And then this guy's 5 lines are going to be like super weak. They're just going to be like, ee, 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 ee. Okay, so see the difference how here we have an even balance. Okay, here this guy's lines are sort of dominating the smaller charges lines and pushing them away. Okay. So you always want to draw your directions on your field lines. So boom, something like that. Let me do the same thing for 2 opposite charges that are, so let me separate all this into different regions. Okay. All right. So what if we had a +2 next to a -1? All right. So what you have in this case is you are going to have the field lines go out, and the +2's field lines are going to go straight for longer. So it's going to be like, they're almost going to like curl around the back. Like this. Okay. So notice how +2 has 10 lines, but -1 has 5 lines. So these are the only lines. So we can't draw any more lines going into this -1. So what happens to all these extra lines that don't connect to the -1? Well, they just go off to infinity. Okay, so so lines either end on a charge, okay, or go to infinity. When I say go to infinity, I just mean they go off and they never come back. Okay, so this +2 is going to have 5 extra lines. Okay, 5 extra lines that just go off to infinity. So maybe like this, like this, like this, like this. I don't know, something like that. Remember, it's approximate. It's approximate. So if you don't draw it perfectly like the computer draws it, that's okay. All right, because it's a useful thing to visualize in your head what's going on. All right, so these are the 2 basics. You should know, what does it look like if you have a positive next to a negative, and what does it look like if you have a positive next to a positive. And once you know those 2 things, you can draw any electric field pattern you want to draw. Okay, so let me show you. Let's do some other examples of drawing field lines. All right. What if I have a +3 charge, and then I have a -1 charge, and then I have a -1 charge. Okay. +3 charge, a -1 charge, and a -1 charge. So let's say that let's say for this drawing, let's say that +1 is going to be equal to 4 lines. Okay? So what I can see here is that I've got a positive next to a negative. All right? So I have a positive next to a negative. And so when I have a positive next to a negative, it does that kind of, it does the, what was I going to say, the metaphase plate thing, where you have lines going over like so, like that. Okay? So there's these lines going over. Then I'm going to do the same thing with these two, right? Because I have a positive next to a negative, but I'm just going to take the picture and rotate it. Okay? Now this whole system obviously is going to have a line of symmetry that's along here, right? Because it's the same if you flip it this way versus that way. So, you know, I shouldn't draw the 3 lines in a different way on this side. It should look kind of the same as best I can. But keep in mind it's just approximate, so it's all right if you mess up. Okay. And then here I have a negative next to a negative. And so when you have a positive next to a positive, you have the 2 lines go out like this. But if you have a negative next to a negative, they go in like that. Okay, so the picture is going to be exactly the same with 2 negatives as you had with 2 positives. Okay. So these guys are just going to have a lines that, you know, kind of go out like this. Or sorry, in. All right. Now we have 6 lines are used, and we need to draw 6 more. Okay, so I will draw 6 more lines, and those 6 lines, because the 4 of the negative one and the 4 of this negative one, they can't have any more lines. So all 6 of the additional lines have to just go off to infinity. So they'll just kind of go woo, 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 woo. I'm making Bug bark when I do that. Woo, 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 woo. It's a call and response. Okay, so it's kind of like that. That's the pattern for that particular arrangement of charges. Okay, so let's do another arrangement of charges. Let's say I have 4 + 1 charges in a square. All right. So here we have a +1 next to a +1, so that does the thing. And so obviously this is going to have lines of symmetry, right? Like this is a line of symmetry of the charge distribution. This is a line of symmetry. So whatever I draw has to be symmetrical with respect to that, okay? So I got off to infinity. All right. Off to infinity. Off to infinity. Off to infinity. Okay. And then maybe I draw 2 L's that go off. Now, why couldn't I have 2 that goes down like this? That doesn't really make sense, because if I did that, I would have to have 2 that come up like this, and so they would kind of like be colliding, right? So because if I had any electric field lines going towards the center, they would be crossing each other, right? They would have to avoid each other somehow, and there's no way for them to do that. So I know that there's no field lines that are going to go into the center. Like that, something like that. So now I have to just draw the directions of the lines. Like that. So there's that example. I'll do maybe one more example of drawing it. Okay. Let's see. Maybe we have a -2 next to a +1. And then maybe there is a -1 here. And then maybe there's a +2 here. I don't know. I'm just making things up here. I feel like Bob Ross. Let's draw happy little charges. So what do we got? Well, here I have a positive next to a negative. So that does the thing. Okay. And by the way, this problem doesn't really have any... Oh, I screwed that up completely. Right? Because that does the metaphase plate thing. My bad. So it does that. Okay. Now I have a positive next to a negative. So again, it does that. And then I have a positive next to a negative. So it's going to do maybe that. So why did I draw this one as almost like arcing around behind? It's because this +2 is greater than the -1. Okay. So you tend to kind of have the field lines arc behind when you have a bigger charge next to a smaller charge. They kind of loop around the... okay. And then I have another one, so maybe I'll do something like this. Okay. Now I have a positive next to a positive right here. So those two are going to do maybe a swing. Like that. And just have this. Boom. Positive next to a negative. Like so. Okay. So now what I have to do, so I have the general picture. So now what I have to do is I have to make sure that the number of lines is correct. Okay. So here I have +1. All right. Charge. And I can see it has 1, 2, 3, 4 lines. So what I will do is I will make the other -1. It's got to also have 4 lines, and I can see it only has 3. So I got to do another line for this one. So maybe I'll do, I don't know, one loops around like this, like that. Boom. So now this one is taken care of. Now I have this +2. So if +1 is 4 lines, I can see that +2 has got to be 8 lines. So this one has already 1, 2, 3, 4. So I got to do 4 more lines for that. 1, 2, 3, 4. And I could try to draw a line in here. So why did I draw these lines on the outside as opposed to going inward? Well, because I know that any line that I draw inward can't go over to this charge, right? Because that's a positive charge. And it also can't go curl around into here because this charge already has 4 lines. Okay. So I don't really have any place for an inward line to go. All right. And then this one only has 2. So it's got to have a lot more lines. It's got to have 6 more lines. So maybe it's... all right, so maybe its lines are done. Something like this. Okay. And then forget about that one. So that's how it works. So now let's talk about interpreting electric field lines. Okay, so what does it all mean? Well, the electric field points, okay, the electric field points parallel, or what am I saying? It points tangent to, the electric field points tangent to the field lines. Okay, it points tangent to the field line. So for example, right here, the electric field points in that direction. Okay, and secondly, the strength of the electric field is related to the density of lines. Okay, so for example, I can see right here there's not a lot of field lines in this area, so this would be a small electric field. Whereas here we have a high concentration of lines, so there's a big electric field right at that location. Okay, so that is how you interpret the pictures that you have drawn. Okay, one of the things that I might ask you to do is I might say, we might talk about putting a charge in an electric field pattern. Okay, so what happens if we put a charge in an electric field pattern? Well, what if I put a positive charge right here? Well, what you want to remember is that positive charge, okay, positive charge is pushed along the electric field. Positive charge is pushed along the electric field. And so that means that this charge is going to get pushed tangent to the field line in the direction of the electric field. So it's going to get a force on it that is that way. Okay. Negative charge is pushed against the electric field. Okay, so what if I put a negative charge right here? Well, I know that the electric field points in that direction, tangent to the field line. Okay, so it's going to point in that direction. So against the electric field would be in this direction. So this one is going to have a force on it in that direction. Okay. Now this is only if they're at rest. Okay. So what students tend to think is that, it's going to flow exactly along this field line and then end up over here. But this is just the direction of the force. So what will happen is it'll start getting pushed this way. So if we think about the actual path the particle is going to take, it's going to get pushed this way and it's going to build up momentum. Okay. And so because it has that momentum, it can't follow the field line exactly. So it's going to kind of like lag behind. It might do something like this. That might be the actual path. Okay. So keep in mind, the field line is not followed exactly by particles. All right. And so this also kind of connects to what I was saying about, remember, you feel the electric field due to all the other charges in the universe, okay? So kind of like this charge right here is you, and you experience the electric field due to all the other stuff, okay? So, yeah, keep that in mind. All right? So that is my lesson for today, and we're going to go to the Zoom room. See you there.